Welcome, Hornets. Today we're going to be talking about finding the values of x for which a series will converge, as well as the function upon which the series is converging upon, specifically an f of x that will yield a sum. So what we're going to do is we're going to start off with a function today, the summation, as n equals 1 and goes to infinity. And I'm going to make sure that we start with an indice at 1 as opposed to 0. Because ideally we want 0. But we have a 1 here. So we're going to have to change this so that our indice that we start with is a 0. Now in order to do this, I'm going to go ahead and I'm going to start by changing the equation into 3 to the x times 3 to the x to the n minus 1. And you'll notice it's still the same series. Nothing has changed. But what it does is it allows me to bring out the 3x into the front so that I have a series that I can work with called 3x to the n minus 1. And you'll notice when I plug the 1 in, it now gives me a 0 exponent, which will allow me to change my base indice, or the first value of n, into a 0, and changing the exponent into an n. Now, with this, I can easily see that if this is f of x, so if this is my f of x here, then what I can do is I can say that f of x is 3x times the infinite sum. And we know that our first term, a sub 1, is 1, and we know our common ratio is 3 to the x, or 3x. So I can write this as 1 divided by 1 minus 3x. This yields the equation upon which I am coming to. This is my sum at infinity, or the equivalent sum. That's 3x over 1 minus 3x. And now the question becomes, well, what value am I approaching? What values will work and give me convergence with this f of x? You see, this f of x will only converge for a small group of x values. And we want to know, what are those x values? So we're going to take our ratio, and we're going to say that it's less than 1, allowing me to factor out the 3, using my properties of absolute values, so that I have the absolute value of x is less than 1/3. That means that my series that I have here is going to now have a sum of 3x divided by 1 minus 3x for the values of x that are between negative 1/3 and 1/3. Now you'll notice how that works. We drop the absolute value. We put negative 1/3 to the left, 1/3 to the right, and this is what we refer to as our interval of convergence. Let's take a look at another example. This time, I'd like to use an example where our indice is already 0. Okay? So let's take a look at the summation. As n starts from 0 and goes to infinity, of 2 over x to the nth power. Now you'll notice this is already set up. Our a sub 1 is going to be 1. Our common ratio is 2 over x. And as a result, we can now find the f of x that we are approaching, or the f of x of convergence. And this is going to give me 1 over 1 minus 2 over x, and we'll get our common denominator, and we should end up with x divided by x minus 2. So this is the function that we're approaching. That's the sum, if you will, our infinite sum that we want. And we're now going to find the interval of convergence. 2 divided by x is less than 1. Factor out the 2. 1 over x, less than 1. Divide both sides by 2, 1 over x, less than 1/2. And now I take the reciprocal on both sides, and I flip my inequality. This means that as long as my values of x are greater than 2 or are less than negative 2, we will have a converging value. So here is my interval of convergence right there. Oh, you can't see it. There you go. The interval of convergence. And this is the sum in terms of f of x, or in terms of x. I hope this helped you, and we will continue to work with this over the next several days, and you will get more practice, I'm sure of it. As we go through, I will point out that we will find other techniques to find our interval of convergence and our radius of convergence that are a little bit easier to work with. Thank you very much, Hornets, and I hope this has helped. Please be well and be safe, and please take care.